Welcome back to Lane's ED Enhancement. We are going to be looking at today the part B of that question that we started. So we'll be looking at part 3B of realistic scenarios. And this is another practical example from the course Seaborne Cargo and Dangerous Goods. Now, today the packing instructions that we were given in B states that how many cartons can be packed as in A, which we would have done in our previous video, but with those in the top layer packed on their sides instead of upright. Now, what B is telling us to do is first to remove those that are packed on the top layer first, pull them out of the container, and then we are going to repack them on their sides. Now, there's another video that I've done stating some detailed explanation, and we call it figures 1 and 2, that you can go and have a look at just to get more detailed understanding, a better and clearer understanding of this. But for now, as the instruction says in B, they want to know how many cartons we can pack just as A, but we are going to pull those from the top layer and we are going to repack them on their sides. So now let us look and see how this can be done mathematically. Let us express it that way. Now, as stated before repacking the containers, we must first remove them from the top layer. So cartons in the top layer to be removed from the container. Now, the total to be removed is as instructed, 6 across, 1 layer, and there are 23 of them on the length. That gives us 138 cartons. Now let us look at doing it another way. The cartons remaining in the container would simply be the total that is there, 2070, and we are going to take away those that are on the top layer, 138, and we get 1932. Another way of doing this is initially we had packed 6 across, 15 on the height, and 23 on the length. They asked us to remove 1 from the height. So it would be 6 times 15 minus 1 times 23. That would give us 6 times 14 times 23, and we get 1932. So you can use either way to calculate cartons that are remaining in the container. Now that we have removed them, we are going to work with the instructions. The instruction states that we are going to turn them over, turn the cartons on their sides instead of upright. Now, in that video, figure 1 and figure 2 will show us that when you turn these cartons on their sides, the sides will remain the same. The sides, which is the length, representative of the length, will not change. They will not change. What will change is that the initial height and the initial width will be changed to a new width and a new height. So what was the height initially will be changed to be the width. Now let us look at this. So they said to pack the cartons on their sides instead of upright. As I stated, figure 1 and figure 2 would show you that in the next video. So the length remains the same, because you're turning them on their sides, but the width will become the new height, and what was the height will become the new width. For example, think of being in a classroom. You're in a classroom sitting at a desk, and you're told or you're asked to turn the desk on the side. So you're going to basically turn over the desk. You're turning over the desk. You initially, what was in front of you is going to be the length, and what is the section that you would put your laptop, your pens, your calculators would be the actual width, and the height would be the distance from the ground of this desk. Now when you turn it on the side, the length won't change, it will remain the same, but what you add in front of you, where your laptop was initially, would now becomes a new height, because it will be the distance from the ground up to the top of the desk. And the new width would be what was initially the height will now be in front of you for you to put something on it, to represent where you can now put your laptop and so on. So when you look at that explanation in the video of realistic scenario part 3b, you will see it clearer, right? Now, the length is 0.4 meters, doesn't change. What changes is the height. So now the width, which was 0.25, now becomes a new height, 0.25. And the height, which was 0.15, now becomes a new width, 0.15. Now let us work out the space available in the container for height. Now, initially, what remained on the height when we calculated A was 0.1 of a meter. They ask us to remove one carton, and the height of one carton was 0.15. Therefore, 0.15 plus 0.1 gives us 0.25 meters. That would be the space that is now available in the container for the height. Here's another way to look at it. The initial height of the actual container is 2.35. And we have been told now that it's no longer 15, but it's now 14. Now, when we utilize 14 times 0.15, we get 2.1 meters. 2.1 from 2.35 leaves 0.25 meters. Same thing. Now, let us look at the space that is available in the container for length. We say it's 5.75. which represent the length of the cartons that are already packed in the container. Because if you're going to repack, then you have to pack on what is existing. And you already have 14 height, which represented on the length of 23 by 5.75 meters. In other words, you pack 23 cartons at 0.25 each width, and that gave us the 5.75. So that is now the space available inside of the container where the length is concerned. Now let us look at the solution for B. We now see that across the width remains the same. The width of the container don't change, and the length of the carton does not change either. And so we have 2.4 divided by 0.4. We get 6, no space remaining, and so we know that across the width can be considered a constant because nothing changes where that is concerned. Now let us look at the height. As we said earlier, the space available for the height in the container would be divided by the new height of the carton, and we worked out the space available to be 0.25, and we are dividing by the new height of the carton, which is also 0.25. So we removed 1 on the height, and we can put back 1. Let us look at the length. The total length of the carton in the container, as we said, represented 5.75. And we also have that to be divided by the new width, of the carton. Therefore, 5.75 divided by the new width, which is now 0.15, gives us 38 with a small increment remaining. 38 times 0.15 would give us 5.7, and the full length was 5.75. Now, let us see how many cartons we repacked. Total to be repacked, we again will use the 6 times the 1 times the 38. And let us see what that gives us. So we have 6 times 1 times 38 gives us 228. Remember, initially we removed 138. If when we did this to determine packing on the sides and we got less than 138, it would make sense we would have removed them. And so we can work with 228 because packing on the side gives us more in the actual container. Now let us see what does part B looks like in terms of number of cartons. The remainder of cartons in the container was 1,932, and we are now going to add 228 to that, and we get 2,160 cartons inside of the container. Now, join me for the final part of the question in the next episode of Realistic Scenario Part 3C. Now remember to go and look at those two videos, the one about the diagrams A and B and the one about figures 1 and 2, which both are going to give you a better explanation of how you will turn over the cartons and how these packing instructions are. Remember to like, to share, and to subscribe to this channel. And don't forget to hit the notification bell so that the next video, as soon as it is available, you will be one of the first persons to know. Thank you very much.